everyone. Okay, so it's really nice to have a talk in front of such a great crowd. And today we are going to talk about the Kubernetes storage. Hopefully after this talk you're going to understand some internals, what is going on when you're using some PV or PVC, so the PersistentVolumeClaim. So this is a basic talk, so even if you don't know much about the storage in the Kubernetes, hopefully you will understand more, or at least you'll understand everything what is going on under the hood. Okay, so let's go. So kind of introduction. So I'm Mateusz Dymin. I work at Nokia, and I came from Java world to Go. Now I'm doing mostly things in Go. I'm one of the organizers of Go Wrots, which is our Wrocław meetup, and you can follow me on GitHub, Twitter, and LinkedIn, of course. So today we've got an agenda, and we are going to talk, and we'll start to talk about the challenges. So what the problems are in the container worlds, and why stateful applications or stateful workloads are kind of problematic in the Kubernetes. Then we'll talk about the volume plugins, and the volume plugins are the heart of the whole storage thing in the Kubernetes. So this is the piece which is ordering the storage, whether it's external or in the internal one. And then we are going to talk about the stateful applications, which is kind of example how to run properly your stateful workload on the Kubernetes. Then we'll talk briefly about some extra fancy features inside the Kubernetes regarding the storage. And then we've tried to have some short myth busters game. Okay, so I'll try to I tried to find out some kind of myths which are anywhere, like on the blog posts in the internet, which are regarding or which are created against the storage on the Kubernetes, and then we'll try to find out whether it's a myth or not. At the end, of course, the summary. So now the whole presentation and the PPTX and the PDF and all the YAML snippets which are going to show are available on my GitHub. So if you are going to make some photos during the presentation, you can do only one photo at the very beginning of this repo, and then you will find everything. This is I have committed changes like an hour ago, so probably it's going to be pretty actual. Okay, can I? So let's start. Okay, one more seconds. Okay, thank you. So let's start with the very basic thing. So very basic thing is like a pod. Okay, so probably like everyone here knows the Kubernetes, yeah? Am I right? So who of you doesn't know the Kubernetes basics? Okay, great. So it's pod, it's called MySQL, it has some containers, in fact it's only one container inside, has some password, passed by the end variables, which is not very important, also the port, and that's it. So now the question is whether it's stateful or not. So the answer is it's not. And why? Because what will happen when the data, with the data, when the container ends this execution? Okay, so that's the question, and the answer is the data is going to disappear, yeah? So everything is going to be removed. So that's the problem, okay? The problem is that the containers and the problems, in general with the stateful containers are that the containers are ephemeral by design. So they've designed to be a kind of a piece of software run inside the container, which should be a stateless. Okay, so this is a like basic concept, and by design it's like that. And the problems, and another problem is that when the container terminates or crashes or anything is going to bad happen with the container, or we just remove it by hand, this pod with this MySQL, then the data is lost. Okay. And then, of course, the containers also cannot share the data, because there is a whole isolation principle which tells us that everything should be inside the container, and we shouldn't share the state between the containers, and so on and so forth. So it's, in general, of course, that we cannot share the data, and we can't run stateful applications, but or unless the storage is provisioned and attached to our container by some external thing, which is volume plugin. So inside the Kubernetes, we've got something which is called volume plugin, which is a piece of software which is ordering and attaching the external volume to our container, okay? So the very first thing, the volume plugin. So what's the volume plugin? So this is a way how we can reference the block device or mounted file system inside to our container, okay? So the volume plugin also order volume somewhere else and attach it to our container, okay? And this plugin has some responsibilities, and the very first one is that we need to describe and tell this plugin how this volume needs to be set up in a pod. So, for example, where the data or the storage should be mounted inside our container, and also, or as well as, we need to tell what would be the path and what would be the external storage, like a Ceph, like AWS EBS, sorry, and so on and so forth. And of course, lifetime of the volume could be longer than the lifetime of the pod. Okay, so the lifetime of the pod is basically it needs to be treated as a short. Yeah, so we need to be aware that the container might die or crashes or anything wrong might be with that. So we need to be sure that the data be somehow preserved. So then we need to use this volume plugin to somehow attach something external, the storage, to our container, okay? And that's what the volume plugin does. So what are the options inside the Kubernetes to get the storage, okay? So the first one is just the file storage. The another one is block storage. There's also a file on block storage. And why is that? And it's that because this is a standardized data path, okay? So we've got the whole POSIX idea, and to attach volume to our container, this external storage thing, which is giving us this extra data or giving us this extra storage, needs to be somehow standardized. So there is no way, for example, to use a Kafka, use I don't know, the S3 or anything like that, because it's not POSIX. Yeah. So that's the basic idea, that only those kind of storages might be attached to our containers. Okay, and here's also the whole types of volume plugins. Okay, so we got the remote one. So those are most popular. So we've got Azure, file storage, GCE, AWS, and so on and so forth. Cinder for OpenStack, and this is basically, those are the most popular, but there are other options, okay? And we'll talk about all of them today. So we'll try to go one by one, by the remote storage, also the ephemeral storage, and try to find out how it works, how it behaves, how it's done under the hood, and how we can preserve the state of the container, okay? So let's start from the ephemeral, the very, very easy one and basic. So ephemeral storage, which might be attached to our pod, is just a file space taken from the host. Yeah, so this is like a temporary directory which is somehow mounted inside our container, and this storage is taken from the host machine. Okay, so there's a host. The Kubernetes runs on top of this host, and now we are attaching the volume based on this. Okay, easy. It's temporary, so when the container dies, the data is lost. Okay, so the data exists only for life cycle of the pod, and it can only be referenced inline. So inside I'll show you an example in a second, but it means that in a pod, when we are trying to attach the volume, we need to type by hand that it's going to be like an ephemeral one. Yeah. And we cannot use this PVC, which is a persistent volume and PersistentVolumeClaim. I will explain those later on. And the plugin is called MTD. So the blue one, so usually when something is important, then it's in the blue box. Okay. So now we are attaching some volumes inside our container, inside our pod. Okay. So what changed? So it's the volume mounts and the volumes. Okay. So now here it's the volume mounts. So it's called data. So the data, it's the name of this volume. So here's the reference. So the data needs to be equals here and here. And it means that the empty dir, so the temporary disk space, is going to be created inside our container inside this path. Yeah, easy. Probably everyone at least runs something like that in his life. But it's easy. It's not very useful because, I don't know, we can use it for tests. But sometimes it's there are some concepts in the Kubernetes which are really useful and are built on this kind of storage, like ephemeral one. And those are the secret volume, config map volume, and downward API. So what's that? Secret volume is just when we have a secret, and now we can have a volume attached to our container, which is based on this this value taken from the secrets. Yeah. So, for example, password. And now we've got a file with password, one or many, inside our container. Same with the config map, which is just a list of the values, like key values, which also can be mounted as a file inside our container. And it's also this based on the ephemeral or empty dir, yeah, idea. And downward API is a kind of set of metadata which describes the container itself, like quotas and version and so on and so forth. So this is also, it could be attached as a volume inside our container, and it's built on the empty dir. Okay, so all in all, we can populate some Kubernetes API calls with the volume inside our Kubernetes. So we don't need to use a Kubernetes API program like from the code just to get the secret. We can just mount it as a file inside our container. Okay. So, for example, config map, it's exactly almost the same as empty dir, but instead of here of empty dir type of volumes, we've got a config map type of volumes, which is based on this empty dir approach or idea. Okay. So, for example, here we've got some configuration of MySQL, which is mounted inside this container from the config map. So now let's talk about the remote storage, and it's more complicated, but it allows us to preserve the state. And now we can save something on a file, and it's going to be or at least lives longer than the container. How it works? Let's start from very basic one. So we are attaching the volume based on this AWS Elastic Block Storage, which is EBS, so AWS EBS, and now we can inline. So we can directly say that this pod needs to mount the volume which is taken from the Elasticsearch. Okay, and now there are some problems with that. So the problems are that the nodes needs to be EC2, and then another problem is that there's instances needs to be in the same availability zone, and the third problem is that EBS only supports a single EC2 instance, okay, mounting a volume. So that's the problem. But the biggest problem is here, that this YAML is not portable, okay? And the biggest advantages and the biggest key principle of Kubernetes is this workload portability. So write once and deploy everywhere, okay? And this file breaks this, okay? So now we've got this EBS, and now we can only run this in the Amazon cloud, okay? So it's problematic. So don't do that, okay? So don't directly reference a volume. It's a bad idea, and there are some other approaches, and there are other ideas how we can solve the problem, okay? So now there are the two key concepts inside the Kubernetes which allows us to get rid of this EBS configuration inside our pod, okay? So this is a PVC and PV. So PVC is a persistent volume claim, and the PV is a persistent volume. How it works? So in general, it's like abstractions. So now, instead of talking about the EBS, we are talking about the claim. So we are talking about this kind of abstraction on top of the physical storage, which is somewhere on our cloud. So now we are talking only about this resource inside the Kubernetes, okay? So how it works? Now in our MySQL pod, we have, here is almost the same thing. So we are mounting the MySQL from the outside, but instead of doing the EBS, AWS EBS thing, and then volume ID, we are saying that it's going to be based on the persistent volume claim, and this claim is called MySQL PV claim. Okay, so it's somehow abstracted from the cloud provider. Yeah. So now the pod is portable. So now we've got this preserved this key approach, this key principle inside the Kubernetes, which is workload portability. So how it works? Now we need to create this persistent volume claim because we referenced it in the pod, but it doesn't exist. So we need to create it. Yeah. So we are creating the persistent volume claim. And what's that? So a persistent volume claim is somehow equals to request for a storage. Okay. So this is kind of a resource which describes how this storage which we would like to get from the Kubernetes should look like. Okay, and what's there? We've got the information about the how it works. So it tells us that give me 1 GB of storage. It should be mountable to a single pod as read-write. So access mode is read-write once, and I don't care about the rest. Okay, so give me that, and that's it. And now the Kubernetes needs to somehow figure out what to do with this claim, okay? How to order in fact, the storage inside the cloud where it's, it's run. So to sum it up, so the application request, it's just application request for storage, and it's created by user. It's also very important because claim, it's not a place where some kind of administrator is creating. Okay, claim is created by the end user who is running the workload. Okay, so it's really important that it's not a kind of administration thing, but it's rather just a piece of YAML which is created by the end user who runs the workload. Okay, it binds to a single persistent volume, so one to one. It's the how they connect, and it's usable in pods. So now we can use this claim in a pod. So we are not using the persistent volume, we are using the claim inside the pod. Okay, so persistent volume, from the another hand, is just this describes how to create in fact the storage in our cloud provider. So in this example we have a persistent volume which has some type, but it's not very important. The important thing is the size. So what would be the size which is going to be ordered somewhere? What are the types of access modes which are supported by this particular persistent volume, and what is also persistent volume reclaim policy. This is important, but we'll describe it in the details in a minute. Okay, but all in all, we need to know that when we delete the claim, sometimes we would like to leave the persistent volume, sometimes we would like to delete it. Okay, and then at the very end there is a pointer to storage. So here is a description how to order this particular storage inside our cloud provider. Okay, so here is AWS Elastic Block Storage EBS, same stuff as it was in the pod, but now it's inside the persistent volume, not inside the pod. So now there is a kind of abstraction between the persistent volume and the pod, and because of that, we can have this portability of workloads. Okay, and of course, all those others remote providers are also possible to put the data here. Okay, so this is how it works in a very, very primitive way. So now we are not talking about the dynamic provisioning. We are going to talk it in a minute. So how it works, how to run this persistent MySQL. Okay, so the very first thing, we need to create a persistent volume. Then we are getting the persistent volume, so we are checking what's the state. So now we can see that we've created a persistent volume, it has a capacity, it has access modes, and it's available. And the status is really important, and the claim, those two things. So status available means that it might be attached to any other container, and it's ready to be attached. And the claim means whether it's already attached to claim and attached to other container. So if it's empty, then it means that the volume, a persistent volume is there, but it's not attached, so it's ready. And what's there? Now we are creating the claim, this mapping between the container and the volume. And if it's created, now we can check that what's changed. Status is bound, so it means that it's already connected with the claim. Okay, And here what is that? Okay, the volume is created because we are checking the claim, and the claim is bound. So if the claim is bound, also if we get the details of the persistent volume, we can see that the claim is already there. And the status is bound as well. So the status is inside the PVC and inside the PV as well. So now they are coupled, and now we can run our pod. Okay? So here, the last step is just to kubectl apply or create our MySQL. And now it's going to work. So as you can see, it's very problematic. Why? Because we need to ask the administrator, okay, please create this persistent volume for me, and then this persistent volume is going to be attached via this claim to my pod. It's kind of problematic, and it's lots of steps to achieve this remote storage and the persistence inside our container. Okay, so how we can simplify that? By dynamic provisioning. Okay, so what's dynamic provisioning? So it's painful and wasteful that we need to call and again our administrator to create this persistence volume. So instead of that, we can set this dynamic provisioning, and this dynamic provisioning is it creates the volumes on demand. Okay, so now when some kind of persistent volume claim, so this request appears inside the Kubernetes, now our Kubernetes understands that okay, it means that new volume needs to be ordered from the cloud provider, okay? And now we need to also somehow describe how this volume needs to be ordered, okay? So, of course, it eliminates this pre-provisioning stage and storage, sorry. So how it's done that this Kubernetes knows how to order this volume from the cloud provider, it's by storage class, okay? So storage class, it's kind of enabler for that. And it defines some kind of characteristics, how to do that, how to order that, what kind of storage it is, and so on and so forth. So now we've got the storage class. It opaques the in fact implementation details, how to do that. Okay, so we don't need to know how to order the EBS. Kubernetes is going to know that. So let's see the storage class, how it looks like. Okay, so here's example. We've got some kind of GCE storage class, and this it's collection of just persistent volumes with the same characteristics, okay? And it's admin thing, and this is not namespaced. So if you create a storage class, this is one storage class for the whole cluster, and usually it's created by the administrator, not by the end user. It's also important. So what are the parameters? So the first one is provisioner, and the provisioner might be hard-coded, or the external, or the CSI. So it's important. We'll talk about the CSI, what the CSI is later on, but right now let's assume that we are using the built-in. So they're called in-tree sometimes. So in-tree means that in fact implementations of those provisioners are inside the Kubernetes source code, okay? So source code, so every single remote storage provider needs to code the way how it needs to be ordered, yeah? So for the AWS, for the GCE, and so on. So this code resides inside the Kubernetes source code. So it's problematic. So that's why they created this CSI, which is kind of interface. Now we might, run it in a different way. But let's talk it later about that. And then we've got some parameters. For example, the type of this persistent volume. It's a standard. It might be PD SSD, which is a fast or faster, or it might be also the zone where this volume needs to be created. Yeah, so we can have a different storage class, for example, fast, and if we'll have a fast one, then we'll have the type PD minus SSD here. Yeah, and then the SSD disk is going to be provisioned by this volume. Okay, a volume plugin. And also there is annotations, and a very important one is that it could be only one storage class which is default in our cluster, and if it's default, then all the persistent volumes is going to be created based on this schema taken from this storage class. Okay, so let's go step by step how it works. So here in this MySQL pod, we don't need to change anything. So it's portable, and we assume that it's portable, so Don't need to change anything now. But in the PVC, in the persistence volume, we need to change something. So here, it was the previous persistent volume claim, and now we've got a new thing, which is a storage class name. So now we are telling, okay, when you are going to create a persistent volume based on this claim, please use this storage class name, okay? And it's going to it's called slow, which is the name of the storage class, which we've already seen. Okay, so how it looks step by step. So we are creating the storage class in the first step, then we are creating the claim, and now we can see that if we get the details of the claim, now we can see that status is bound. So it means that the persistent volume is already ordered for this claim. So it means that we, in the previous example, we needed to create a persistent volume by hand. Now we don't need to do that. Okay, so this is called dynamic provisioning inside our Kubernetes cluster. And now we can also get the PV, which is persistent volume, and we can see that it's also bound. It has a claim, so the persistent volume has been created. And of course, the last step is just to create the MySQL pod. Yeah, but it's obvious. So what will happen if we'll delete the PVC? So what will happen if we delete the pod or we delete the persistent volume claim? So then there is also extra field, which is called persistent volume reclaim policy, and we can describe it inside this in PVC, and it means, and it describes what should be with the persistent volume when we delete the claim. So the options are, there are three options. One is deprecated, so I'm not going to talk. It was with the SEF or NFS, I guess, where we could have some recycle, which just deletes all the data inside this this volume, and it might be attached to another container, but it's deprecated. So now we've got a delete and a retain. So it's really important that if we'll call it delete, then the persistent volume is going to be deleted, but also the volume inside the cloud provider, like AWC, EBS, is also deleted. Okay, so it's important if you set this delete. And the retain means that it's going to leave the persistent volume. So it's going to remove the persistent volume claim, but not the persistent volume. And all in all, the persistent volume is kept inside the Kubernetes, and now the administrator needs to do something with that, whether it's going to be deleted by hand or whether it's going to be reattached to some other container. Okay, so now let's talk about the stateful applications. So the stateful applications are the, for example, applications which, like a distributed database, or applications which have some state inside it. Okay, so what's that? So let's assume that we would like to have applications which is scalable. Okay, so we based our applications on the deployment, and now we would like to have we need to know that when the pod is deleted, also the deployment automatically create a new pod, okay? And it's scalable, and all pods share the same PVC, and this is important. Why? Because if we use a deployment, and also the deployment has a replication set to three, and we have a PVC, then now we end with the situation where we got single PVC for 3 pods, which orders only 1 PV, and now there's a problem. What's the problem? It's that most applications just refuse or crash, because now we've got one single volume which is mounted to 3 pods, okay? And now if you've got a scalable database, it's going to, something bad will going to happen, okay? Definitely. So we need to have a better approach than the deployment to run stateful applications. And it's called StatefulSet. So that's why they've created a StatefulSet. So what's that? It's almost the same as the deployment, but it has also the kind of template which tells to Kubernetes how to order the PVC and the PV for each pod. Okay, so when the pod is deleted, also the StatefulSet automatically redeploy the pod as previously, but each pod has some kind of identity, and now when you have 3 pods, the 3 PVC is going to be created. So each pod is going to order a new PVC and new PV, and in that way we are, running stateful applications. Don't use the deployment; it's going to, bad things going to happen. Okay, use a StatefulSet. What's the difference? Inside the StatefulSet, there is an extra part which is called volume claim template, which is a piece of YAML which describes how to create the in fact PVC for each pod. Okay, So here is almost the same thing as in a claim. I've compared it to the pod, but maybe it was a better idea to combine it with the claim. But in a claim, we've got also the same thing. So what would be the access mode, what would be the storage class name, and what would be the size of the storage. And now, for each pod, based on this template, new PVC and new PV is going to be created. Okay, so it's important to run not the deployment if it comes to stateful applications, but StatefulSet. So now let's get back to the types of volume plugins. Okay, so we've covered remote storage, we've covered ephemeral storage. There are two still on the board which are not blue, so it means that we need to cover them. There's also host path, which is really nasty thing and don't use it at all, to be honest. Maybe if you know what you're doing, then it's okay, but nevertheless, it's not recommended to use it in a production code. So we've got a local persistent volume and out of 3. Which is, I guess we're going to talk about the CSI. So local volumes. So sometimes, and the end users of the Kubernetes notice that sometimes when we are running the new VMs, those VMs have some nice disks, like SSD, a local one, and it's really fast. And now every persistent volume and persistent volume claims were based on the remote storage. That was this kind of standard. But they noticed that maybe it would be worth to run the PVC or the PV based on the local storage, which is going to create and mount the volume inside our container based on the physical disk which is attached to the volume already, okay? Which is attached to our VM on which the Kubernetes is run, okay? So it could be used as a PV, and it exposes a local block or a file as a persistent volume. So it's really nice, but it reduces durability. So we might imagine that our the whole node is going down, okay? And then we've got a problem. So the problem is that we have a situation where there is still a problem that the data is lost, the node is down, and the Kubernetes cannot reschedule the pod on the same VM. So the data is lost. So we need to be really careful about these local volumes. But if we'll run applications like caches, where it's not very important sometimes, and we can lose the data, it's really worth to use it. Okay, and sometimes if we have, for example, Cassandra or Kafka, which are replicated by design as a matter of implementation details of a particular technology, it's also sometimes worth to use the local volumes. It's extra speed. So there is a talk on the KubeCon in Barcelona in this edition, and the benchmark says that it's as fast as bare metal. Okay. So in fact, we are touching the volume which is on, for example, local SSD, and it's extremely fast. So sometimes when you looking for extra speed of the disk, it's worth to use this local volume. So it's useful for building distributed storage systems like Kafka, Cassandra, and other stuff, and also for high performance caching. And Kubernetes takes care of data gravity. So if your pod is going down, then Kubernetes knows that this pod was run on this particular VM and is going to reschedule this pod on the same VM. Okay, that's how it works. It's nice. It's pretty new. I guess it's stable since I don't know 1.12, I guess, or 13 version. And you can reference this via this PV and PVC. So it's it's still the portability is preserved. And now let's talk about the CSI. So the CSI is not crime scene something, which is like a TV series, but it's a container storage interface. So what's that? People from Mesos, Kubernetes, and other companies, all of them were struggling with the same problems. The problems were that they need to order Cinder volume or Ceph volume or anything like that. So they've encountered, they've found a solution that maybe let's create one single interface, somehow abstract that, and do not put the source code of the volume plugin inside Kubernetes or a Mesos, but instead of that, run it as a container and use it via the API. Okay, so they've created a stable API, and now you can use this CSI thing. Okay, it's really nice. So now implementing one single CSI, it solves the problems on all the platforms like Mesos and Kubernetes. Okay, so how before the CSI, the volume plugin was inside the Kubernetes core. Yeah, so the code was there. So that was the problem. Okay, so the problems were that it was extremely coupled, the code of this plugin to the Kubernetes, and also the problem was that there were some bugs, and the bugs might also break the whole Kubernetes because the code was inside the core things inside the Kubernetes. And also sometimes there was the problem that there were some third-party companies that they didn't want to open source their piece of software which was ordering the volumes, somehow. So now it might be that they install the plugin from the outside of the open source world as an interface to the Kubernetes, and then use it as an external piece of software. Okay, so concept is that this is pluggable, this storage interface, and now we can have the storage providers. So all in all, now they are moving all that stuff from the source code of the Kubernetes to the external repositories, and all the cloud providers are doing implementations of this CSI. Okay, so they are moving and implementing that, and now I guess that the approach is that they are going to proxy that. So from this in the storage class, the provisioner would be exactly the same, but under the hood is going to proxy the whole request via this CSI component to order the proper volume in and storage in Amazon and so on. So example is that the provisioner is now not Kubernetes.io/EBS something, but it's a CSI driver example.com. It might be GCE and AWS and so on. And there are also some extra information about the secrets. So this is how it's going to work. If you're interested, there is a web page and also specification and 2 great talks about that. So now extra features. I've found 2 extra features which are really worth to talk about when it comes to the storage on the Kubernetes. The very first is the resize of the PV. So now we can resize like kind of dynamically the persistent volume, even if it's already attached to the container. Yeah, the problem is that it's offline, so we need to turn off the pod and then resize it and then turn it on. Yeah, it's problematic, but they're working on the online thing, which is alpha, and it's based also on this CSI. So now they've created this CSI interface, and then there is a special method which is a resize. And now, if the, for example, particular cloud provider supports this, resizing, then it's available. And also another thing is snapshots. It's also based on the CSI. And it also allows us to make a snapshot on the persistent volume. So sometimes you would like to have this just a backup of the data. Yeah, so it's also possible. It's part of the CSI. So there are extra CRDs which are called volume snapshot content, volume snapshot, and volume snapshot class. So you can imagine that volume snapshot content is persistent volume, volume snapshot is PersistentVolumeClaim, and the volume snapshot class is a storage class. And it works in the same way somehow that is going to, call for example, Amazon. Okay, please give me the snapshot. And it also it's based on the CRD, so the proper resource inside the Kubernetes is created. That this is a snapshot of this particular persistent volume, and that are also bounded. So you cannot, for example, remove the persistent volume because this persistent volume has some snapshot, which are attached to the persistent volume. And it's a really nice article how it works under the hood. Okay, so mythbusters. So quick game, 4 myths, and let's try to find out whether it's a myth or not. So the first one is that applications in the containers must be stateless. Hopefully, after this talk, you know that it's not true. So yeah, they are stateless unless the persistent volume is used. Okay, and the statistics shows that 40% of the workloads, somehow that people in the Kubernetes measure that, are stateful. Okay, so it's not that only stateless applications are run. For example, database creators like Kafka, Cassandra, they are doing the operators for the for the technology. So in general, the approach is that we are moving to Kubernetes. Yeah. Even if the speed maybe it's a lower, so it's a myth. Okay. The second one is writes done by container apps are slow. So if we'll use a host path or a local volumes, those writes are almost the same speed as a bare metal installation. So it's not true. When we properly configure the Kubernetes and we set the pod affinity, pod anti-affinity, and we dedicate some nodes to, for example, Kafka or Cassandra, then we might achieve almost the same throughput and latency as on the bare metal. So it's kind of myth, but when we just use a standard provisioner and order the EBS, then of course it depends on the cloud provider. Yeah, so it depends on the storage, depends on the cloud providers. So you need to test it. So I recommend the sysbench and pgbench tools to run your own tests based on cloud provider storages. And also there is a nice talk about the benchmarking cloud native storage, which is done by Josh Berkus on this KubeCon. So it's not a myth, because it's true, but if you use a local path and you know what you're doing, local volume and you know what you're doing, then it might be really fast. So storing data on Kubernetes requires remote distributed storage. It's a myth. You can use a local volume or a host path, but you need to be very aware of what you're doing. Okay, and never run DB on Kubernetes. So it's a myth, but if you have a choice to run DB as a service in AWS, so it's always better than to run it inside the Kubernetes. Because of, monitoring, observability, and other stuff which you need to do by hand when you run it on the Kubernetes. So let's sum it up. And so hopefully I've got a few takeaways. So if you leave this room and there are 3 sentences which you would like to remember from this talk. Hopefully you will remember that the storage on the Kubernetes is not that complicated. Like the PV and PVC is, it's quite complicated, but not that much. And that the persistent local volume is almost as fast as the bare metal. And never use the direct references, because then you break the whole concept of portability of workloads. Use dynamic provisioning all the time, and remember about this difference between the deployment and the stateful set. And still DB as a service is better, but not cheaper than DB on Kubernetes. Thank you. That's it, what I've prepared for you today.
So basically, when you use stateful set, you create a couple of PV and PVC. Yeah. So the application must be designed that don't use the same data. Yes?
If you're using the stateful set, then each pod is ordering the new PVC and new PV. So each pod has its own storage. So there is no way to conflict or write the same data twice or something like that.
The same about this stateful set, because you provided the example with the MySQL. And
it's not very good example. Yeah, I know. Yeah, but I didn't want to mix, up with your heads that we had tons of examples with MySQL, and then I will just come with like Cassandra or some distributed one. Yeah, but you're right that maybe this example is not the best.
I have one question about dynamic provisioning.
Yeah?
Could you please tell me if we have any possibilities to set some boundaries about kind of number of disks which any developer can provision, for instance, for remote storage at cloud, because it can lead us to some, wasting of money if some disks were left?
Yes, of course, we can set a quota based on the storage class. So, for example, we can allow so that the maximum number of disks is going to be that or that, and the size is going to be that or that. It's also possible to set a quota based on the storage class.
One more question, another one here.
Thank you. Hello.
Yeah. Hello.
So my question is, we all know the disadvantages of running databases in Kubernetes, and pretty much everyone tells us to run RDS or Cloud SQL or something. So my question is, what is the reason you would personally find a good reason to run database in Kubernetes actually? So when is the moment?
Okay, so I guess that the answer is that depends on the, for example, type of database. Because if it's like a distributed one, then probably I would choose a Kubernetes. Because if it's Cassandra, then it's pretty easy to run it. Then it's pretty easy to run it as, for example, from the operator, and the operator tries to, preserve the state that we need to have a 3 nodes and so on and so forth. So this is really nice. But if it's going to be like a single SQL database, that's I prefer the SaaS model. So that's the one thing. The other thing is that sometimes it's really nice, and there are some extra features like this, fault tolerance, for example. So if I've got a Cassandra and I need to figure it out how to manage the faults inside the VM, and this, this Cassandra is run outside of the Kubernetes clusters, then probably I would just use the Cassandra inside the Kubernetes, because it's much easier for me to somehow make the whole monitoring, the whole operability on top of the Kubernetes. Yeah. So that's the reason. But if someone came to me and said that the performance is critical, probably I would run it outside. That's the one thing. And also the single SQL database also, I would rather run it on outside the Kubernetes.